My name is Nicolò Cairo, Project Officer at ETN Global. And today's webinar is on the overview of the CHP market. And today we are going to have two presentations with our two speakers. So Hans Korteweg, Managing Director at COGEN Europe and Executive Director of COGEN World Coalition. Hans will provide us with an overview of the cogeneration trend in the world and also a special focus on Europe. Following the first presentation, then we'll have Ods Russell, Industrial Policy Officer from the Association for Decentralized Energy Systems, with a specific presentation on the CHP market trends in the United Kingdom. So before I give the floor to Hans for his presentation, I'd like to thank both Hans and Ods for their availability and interest to present at our webinar today. So thank you very much. And Hans, please, the floor is yours. I will stop sharing my screen.
Thank you, Nicolò. And thank you to ETN Global for this initiative in these webinar series. And we're very happy to take part in the first. And my presentation, as mentioned, will focus on the global level, and then looking a little bit further down at a continental level, and then with a specific focus on Europe. So the first presentation is from the perspective of the COGEN World Coalition. A few words about that organization. It was recently set up. It's only about 2 years old. It was set up to establish an international platform for the cogeneration sector to interact with intergovernmental organizations, to connect companies, entrepreneurs, associations, professionals, to provide information about cogeneration, and also to support the establishment of national and continental associations around the world and bringing them together in one platform. So this is just a very quick overview of our membership. We have 13 different national associations spanning across the globe. The most recent to join are coming from India and Japan, and we also have a number of corporate members representing manufacturers as well as the supply chain. Moving to the global perspective, should premise that this information, the data, is coming from the International Energy Agency. So it is the latest available information from the IEA, and that takes us to 2019. But I think it provides us a good overview, and we look at everything from a 10-year spread. So looking globally, there's around 4,000 terawatt hours of CHP around the world, representing around 16% of the electricity generation share. We can see that there's been an increase, in fact, of CHP electricity over the output of almost 1,000 terawatt hours in the last 10 years, between 2009 and 2019. And then given the same period, we see CHP output also went up from around 8,400 terawatt hours to 11,200 terawatt hours. Looking at the fuel mix, today we see that fossil fuels still continue to dominate, with coal leading the way at around 60%. There is a growing share of renewables, specifically more on biofuel, biomass. There's a growing share, and it's around 6% globally. But as things stand today, about 95% of the fuel mix share is held by 3 different fuels, specifically coal, natural gas, and then biofuels and waste. We do see some trends. There is the gradual phase out of coal, obviously not fast enough. There is a further electrification of industry, which is certainly positive. And then hydrogen CHP technology is gaining ground, specifically probably in Europe and North America. There is a growing acceptance. However, the economics is not there yet, and the volumes are not there yet today. Looking at North America, there's around 330 terawatt hours. There's been little variation of the electricity output, which has been ranging between 325 and 350 terawatt hours, and the electricity share remains fairly steady at around 6.5% since 2008. The main fuel used in North America is natural gas, followed by biofuels, waste, and coal. We see a small share of solar, wind, and other CHP in the fuel mix, especially in the last couple of years. Moving from North America, we go to South America. This is a relatively small but growing market. It has around 87 terawatt hours. We don't, unfortunately, have the CHP heat output, but we do have the CHP electricity output. But the share has a CHP share in total electricity in South America has been around 6.7%, and it's actually increased significantly in the last couple of years. We see that biofuels and waste are actually the main category that dominates CHP fuel markets in South America, and by far the largest market is Brazil. And Brazil uses sugarcane waste residue to fuel the CHPs in this market. We don't have time to go specifically into Brazil, but the market is, I think, almost doubled, and it's specifically related to Brazil, and it continues to grow, in fact. Looking at Asia, which is by far the largest market for CHP, there we see an increase of the electricity output from around 2,000 terawatt hours to almost 3,000 terawatt hours. Despite the increase in output, the CHP's share of electricity has actually decreased due to the demand and increase in electricity generation in Asia. So it's decreased steadily from about 22% to 19%. Right now, we see that Asian electricity markets are prioritizing other technologies. The main fuel remains coal. The main fuel remains coal, and this is due to China's very high consumption of coal to power in CHP. And China is the largest market in Asia, and actually the largest market in the world. It represents half of the CHP market globally at 2,000 terawatt hours. It represents almost 60% of all CHP electricity produced in Asia, so a significant market. It's in terms of the fuel mix, it's mainly coal products, but we do see trends there switching from coal to natural gas with the view to eventually replace natural gas with decarbonized gases as they become technically and economically available on the market. Again, with Asia, you see a small decrease in the CHP electricity share in the total electricity generation, going from around 33% to 27%. And that's basically Asia. This is the only country we look at more specifically globally, with the exception of Europe, but it's by far the largest market, so I thought it was important to highlight this particular market. And here, again, we don't have the heat output due to the availability data from the IEA. A small market, but a growing market, is Africa. You see an increase of the CHP electricity output from 110 gigawatt hours to around 700 gigawatt hours. The share of CHP electricity output is relatively small, insignificant. In 2019, it was approximately 0.08%. And according to the data from the IEA, CHP is mainly powered by biofuels, waste, and natural gas. A lot of this has to do with infrastructure, especially when it comes to CHP with natural gas. There's not a developed, say, natural gas network that we have, for instance, in Europe and in North America to allow for the use of a lot of natural gas that is actually available in Africa. And this is my last slide when it comes from a global perspective, just an overview of the current trends and the future trends in the CHP market. Looking at the current situation from a geography perspective, you see Asia Pacific accounted for a majority of the CHP market, over half of the markets. Europe and North America are fairly developed markets as well. We do see growth in India. India is also driven with sugarcane, in fact, and China due to industrial growth, expansion, and further technological innovations and support at various different levels of government. In terms of looking at forecasts, we see a steady growth in South America, in particular in Brazil, as I mentioned before. The technologies that are being used in CHP application is mainly gas and steam turbines. They were the two main technologies that we see. However, fuel cells, for example, are expected to be used increasingly in the next years to come. Japan has a fairly established fuel cell micro CHP market, for example, and Europe is, I would say, well, it's not far behind, but it's growing in terms of its market, and you see that further application of fuel cell micro CHP in the US and in South Korea. The predominant fuel has been mainly natural gas and coal. However, we do see a transition from coal-based generation to cleaner power generation, such as gas. And as other decarbonized fuels become available, depending on where you are in the world, we see greener gases being used in CHP, maybe biogas, green hydrogen, and so forth. Biomass obviously is an important and growing share as well in terms of fuel. In terms of size, you have large capacity plants that are dominating the market because they're predominantly used in the industrial sector. You see a high demand in the future for up to 10 megawatts capacity for residential and commercial users, and more use of micro CHP to replace domestic boilers, for example. In terms of end users, it's really the energy intensive industries such as the chemical industry, pulp, paper, that are currently the main end users of cogeneration. And then behind that, we have commercial residential facilities, hospitals, universities, district heating, for example. Looking to the future, we see an increase again in the commercial and residential CHP installations, especially for cities at a district level and utilities. And then power heat produced by utilities can also then be used on site, stored, distributed at a local level to facilities, and so forth. So that is a very quick overview of the situation globally, very high level. All of this information is actually available on the CWC website. This was based on the first global market report that we published last year. The second updated global market report based on 2020 statistics from the International Energy Agency will be made available towards the end of November, beginning of December. We'll organize a webinar. If you're interested, go to the CWC website. That was it for global, and now I'm going to share the results of the COGEN Europe National Snapshot Survey. The latest results are from last year, from 2022. And this is a macro exercise using experts from our national associations and partners from around Europe to get an idea of the trends that we see in Europe, areas of growth, areas of shrinkage in terms of installed capacity, electricity generation, and so forth. Very quickly about COGEN Europe, we represent both national associations, 14 different national associations from around the world, as well as corporate members, and we have around over 50 different corporate members spanning across the whole value chain, from manufacturers, the OEMs, the supply chain, to utilities, ESCOs, and then end users all around Europe, different technologies. We are basically the European Trade Association representing the cogeneration industry in Europe, specifically focusing on EU policy, EU legislation, so working with the European Commission, European Parliament, and member states vis-a-vis the European Council. We have a vision. This is something that was at the forefront, at least in 2017 to 2018, and it still remains valid, where we are committed to creating a resilient, decentralized, carbon neutral European energy system by 2050, where we see CHP as its backbone. Now for an overview of CHP in Europe. So this information is actually based on the Eurostat, which is also lagging behind in terms of availability of data. We're actually expecting in the coming weeks to receive the data for 2020, but it's a very complicated and cumbersome process, and it takes a lot of time for Eurostat, the official statistical office, to get the information from member states. So we have around 113 gigawatt electric of high efficiency CHP in Europe, and that by definition means you have to have at least around 10% primary energy savings. So if you discarded the 10% primary energy savings, we would have 350 gigawatt electric installed CHP in Europe. CHP generates around 12% of the total electricity, and it's been relatively stable, fluctuating between 11 and 12%, and about 16% of the heat in Europe. And we know that with the right policies in place, that share could actually be doubled in terms of the total electricity and also the heat output across Europe. CHP across Europe reduces up to 150 million tons of CO2 a year. It saves around 30 million tons of oil equivalent of primary energy savings today, which is equivalent to the emissions of around 90 million cars. In a couple of years, we'll have to change that with more plug-in hybrids and electric cars moving around Europe, but just to give you an idea of the orders of magnitude. And thinking about Europe and thinking about the move away from Russian gas imports, just looking back to 2021, through the use of high efficiency CHP using natural gas, we still saved up to 15 BCM of direct natural gas, which is about 10% of the Russian imports 2 years ago. Moving on, this is just a quick overview of CHP by country. Every country is different. There are geographical, climatic reasons, there are policies in place, there are incentives in place or withdrawn that has an impact on the share of CHP in terms of installed capacity, but also in terms of the CHP share in total electricity. So Germany is by far the largest market in terms of CHP installed capacity, but then if you look at a country like Latvia, the CHP share in total electricity is fairly significant. Looking at the fuel mix in the EU over the past 10 years, natural gas has remained relatively stable, fluctuating between 40 and I would say 45%. What's remarkable is the increase of renewable fuels. Today it's reaching close to 25%, and that's basically doubling it in the past 10 years. And we see a steady decline in the use of solid fossil fuels, lignite and coal, and that's being actually taken up by biomass in particular. Now, quickly, just a high-level overview of the results from our cogeneration snapshot survey, which represents about 90% of the installed capacity in the EU 27 and Turkey. So here is an overview of the market developments in Europe between 2020 and 2021. Just so you have an idea of the methodology, we ask the same questions every year, and we benchmark it. We've been doing so for the last 15 or 20 years. So in CHP, installed capacity has remained relatively stable. There's been no change. You see some growth in countries like Germany, Poland, and Turkey. And then unfortunately, you see some decreases in the Iberian Peninsula, and in particular Spain, due to lack of political direction, I would say. Then if you look at CHP electricity production, again, it's been relatively stable with some growths in Finland, Poland, and then again, some decline in the Iberian Peninsula. The main growth segments include natural gas and renewable-based CHP, and that is basically spread evenly between industry and commercial sectors. In terms of national policy frameworks, we look at different national plans. For example, member states have to submit national plans on energy and climate. There's a heating and cooling obligation under the Energy Efficiency Directive, and so forth and so forth. And CHP remains to receive high-level support for CHP in these various different plans. You do see some unfavorable policy framework in markets, and that's to do with auctions, capex supports, tax incentives, capacity payments are emerging, and flexible tariffs. Other types of support that are coming and going are feed-in tariffs, feed-in premiums, green certificates, and a lot of the problem CHP operators face is the inadequate level of support or unpredictable support, where one day you're receiving incentives, the next day you're not, which makes it very difficult from a business plan. And this is just an overview of relevant quotes that we extracted from the heating and cooling plans on CHP. Looking at Germany, they see CHP working and complementing the uptake of heat pumps, also with the potential for cogeneration to store heat. And that would, of course, then reduce pressure on the grids, especially in the winter when you have a seasonality effect and the peak demand in electricity. CHP is seen as one way to relieve that pressure on the markets, on the grids, I should say. Looking back to last year and probably the first half of this year, there's been an impact, obviously, because of the energy price crisis on the CHP sector. You see, in some cases, reduced operation due to high gas prices, and also different policies being put in place by different governments, as well as another layer of policy coming at a European level has provided some distortive impact on the emergency support that different member states were providing different sectors. There's also been incentives for fuel switching, in particular from coal to natural gas. In some markets, we do see some delayed investments in new capacities, in particular in the Czech Republic and Germany. But you also see some increased profitability of existing CHP due to favorable spark spreads. And you see that in Germany, the Czech Republic, Finland, and in Turkey. So moving to a 5-year outlook, we always ask this question as well to the national experts. And according to them, over the next 5-year period, we see growth expected in around 60% of the CHP markets in Europe, in particular in countries like Sweden, Germany, Poland, Turkey, and so forth, with some decline in Portugal. Other markets are still relatively uncertain, such as Spain, France, Belgium, Greece. And then finally, just a few high-level takeaways from the snapshot surveys. I mean, the key drivers for CHP uptake include the increasing role of resiliency that's needed, as well as flexibility in electricity markets. And then through different policy initiatives, you see a higher value for energy efficiency, especially high-efficiency CHP. Of course, there are still challenges, especially at a policy level. We see still a siloed approach to energy systems. We see better energy system integration, in particular at a local level. And moving forward, we see a bottom-up approach would be more sustainable for CHP as opposed to a top-down approach. You do see still insufficient policy support in different member states. And that has, of course, had a knock-on effect in terms of the predictability of the investment environment for CHP in different countries across Europe. So that was my final slide. I hope I kept the time, Nicolò.
Absolutely. Absolutely, yes, Hans. Thank you very much for the interesting presentation. It is interesting to see the different perceptions and the different status of the market in the European countries, also the comparison with the other regions. So I actually noted down a few questions for you, but I propose, as written in the agenda, to go first with the presentation of Odds Russell, and then we can collect all the questions and we create a question and answer session with our audience.
Sure,
So,
happy to do
Hans, thank you very much again for the presentation. And now we are going to have some further details on the CHP market in the United Kingdom. So, Odds, the floor is yours. I will mute myself.
Okay, great. Can everybody see that all right?
Yes.
Okay, hello. Thanks a lot for having me here. Very excited to talk a bit about the CHP market in the United Kingdom and the kind of different historical trajectory that this has gone on compared to a lot of its Northern European neighbors, and why the UK CHP market has remained relatively more narrow than those of similar geographic and economic partners such as Germany or the Netherlands. But first, a bit of an introduction for myself. So I'm the Industrial Policy Officer at the Association for Decentralised Energy. So my brief covers everything industrial decarbonization, from hydrogen to electrification to the difference in support for clustered versus dispersed sites within the UK. And the Association for Decentralised Energy is a trade association with over 160 members across 4 different policy streams. So there's industrial decarbonisation, energy flexibility, domestic energy efficiency, and heat networks as well. Traditionally, the ADE has been heavily CHP focused, especially in terms of the industrial side. So when the association was founded in 1967, it was known as a district heating association, then the Combined Heat and Power Association, and since 2015, the ADE. We're still the leading trade group for CHP, so we represent a pretty wide range of both CHP engine manufacturers, people working behind the meter, and then end users as well. So people with embedded CHP like British Sugar, Exxon, Tata Chemicals, etc. So first, a bit of a broad overview of the history of CHP in the United Kingdom. So in 1917, St. Marylebone Electricity Department in central London started supplying the Public Health Committee's disinfecting baths with steam from its power station boiler house, the former finding the arrangement lucrative and the latter saving itself considerable expense and trouble. But such schemes generally remained curiosities. They were notable because they were exceptional. Manchester, Marylebone, and London, and above all Dundee, were the initial staging grounds for combined heat and power in district heating. As you can see in this picture from Manchester in 1911, it was in these heavily urbanized, concentrated centres where CHP was able to thrive initially. But these schemes eventually became uneconomical for a number of reasons, mostly because of the results of poor planning, which would unfortunately constrain the CHP market afterwards, as the only schemes that advocates could point to had been, for the most part, costly failures. After World War I, fuel efficiency became a pressing concern, and CHP was adopted by many private industrial actors, but little was done to support it at an institutional level, as most believed that private generation would ultimately be replaced by public utilities. Networks of engineers emerged that advocated for CHP throughout the 1920s, 1930s, and then onwards throughout the Second World War as well. After the end of the Second World War, there was a more favorable environment for CHP and district heating. This is because of the victory of the Labour Party in the 1945 elections, the destruction of large parts of Britain's urban fabric, and new social programs for them to clear out slums in favour of new towns and social housing. So schemes that were proposed were quite ambitious. There were 3 in central London, 1 in Coventry, 1 in Birmingham, again, still in the big industrial heartlands of Britain, and then a lot in the new towns that were being built as well, so the likes of Swindon in the south of England. But due to contingent factors and escalating costs, almost all of these were pared back. Local authorities also had very weak powers and were reliant on commercial decisions about heat loads from private actors that were largely outside their hands. Since local authorities had no general powers for regulating district heating or electricity as well, they relied on local bills being passed through Parliament, which meant that the process was incredibly laborious, completely unpredictable, and it led to most of these schemes dying off completely. The British Electricity Authority, which was the public utility for electricity in the UK, did its own feasibility studies in the 50s and pursued a few promising possibilities, albeit as a sideshow. As late as 1957, it evaluated, at first very favorably, a major scheme from Bankside in London. Publicly, the BEA remained mildly pessimistic, but privately, its attitude slowly hardened as the implications of CHP stations outside of its ownership or of CHP operation of its own stations became clear. With the former arrangement, it foresaw difficulties in controlling the quantities and timing of power, which it might be obliged to buy from a proliferation of small generating stations, and with the latter, it anticipated having to divert scarce capital. In either case, it would have needed extra staff and expertise in what it regarded as a subsidiary activity. Its actions became consistent, though it never declared a firm policy, and it treated each proposal on its merits. Essentially, however, physically and in policy terms as an adjunct to its main activities, and strictly without subsidy. In the 1950s, the BEA was able to continue to handle CHP case by case with the sort of stringent economic appraisal that was not applied to its mainstream activities till years later. So essentially, the social benefits of CHP were completely sidelined, such as reduced pollution, better quality heat for poorer residents in cities, and more efficient use of fuel. CHP was seen as marginal to the main thrust of the growth and operation of the supply industry in large centralized condensing stations, increasingly remote from the major heat loads in cities. CHP could only be contemplated or accepted if it did not interfere with the main business in a specific combination of conditions that became ever more unlikely of time. So the eventual outcome of the visionary plans for heat networks in major cities and many smaller proposals around the country was a very small handful of district heating schemes. Many were much reduced from their planned size, and they were fated to run into severe technical and financial problems. Throughout the 1960s, the overwhelming focus was on large remote power plants, mostly nuclear, that were beginning to replace coal generation. As a result, the public utilities were generally dismissive of CHP. Few supports were provided, and economic criteria for district heating became increasingly strict. With the oil crisis of the 1970s, however, the focus once again turned towards energy efficiency, although the debate had progressed depressingly slowly since the end of the war. Most energy actors simply carried on as before, and the very limited resources given to district heating led to a perceived free-for-all from different cities for limited contracts. Challenges to the industry came in the form of increased attempts to establish CHP outside the public supply system, however, like the boom and mini CHP plant for small sites. To improve the conditions for such schemes insofar as the industry had control over them, particularly through changes in arrangements and tariffs for buying electricity from outside the grid, to involve the industry in specific projects, and to change its framework to induce greater activity. CHP was not adopted en masse in this period yet, but steadily began to establish itself in public debate as a credible alternative to the centralized power stations of yesteryear, and as an alternative to the likes of nuclear or coal generation. Following the privatization of British gas in 1986 and the dash for gas in the 1990s, CHP and industry grew rapidly with the installation of gas turbines and steam boiler plants, and within the commercial sector and hospitals with the installation of gas engine plants. Today, due to the reduction in plant size and the requirements for greater operational flexibility, gas engine CHP has become the leading technology of choice. So why did UK CHP develop so differently from the rest of Europe? UK CHP has always been a lot more concentrated within industry for all of these reasons outlined. So local government was weaker and wasn't able to impose district heating plans upon local areas. Gas networks were quite strong, coal networks as well in terms of lobbying the government against CHP. And then when liberalization eventually came throughout the 80s and the 90s, there was a taboo about central planning of any kind or enabling for CHP, either through subsidies or through removing a lot of the barriers that had existed. However, with the a positive spark spread in terms of the cost of gas and the emergence of a lot of new utility companies that were able to export both heat and electricity, you did see the steady growth of CHP, especially throughout the 90s and 2000s. So I have a few graphs here just to kind of demonstrate where the CHP market is in Britain at the moment, and how it's developed over the past couple of decades. So this is just the total gas demand versus the CHP gas demand over time. So you can see total UK gas demand minus CHP is around 787,316, and then CHP is 60,000. So as gas demand has steadily declined through more renewables coming online, through the better use of efficiency throughout various schemes, you've seen this decline in the general demand for gas, but a proportionally lower decline in CHP gas demand, which means that even though there is less gas demand and there are fewer sites for CHP in the UK compared to a few years ago, it makes up a larger proportion now than it did throughout the 90s or the 80s. The next graph is just about the industrial heat production of CHP versus the UK industrial heat demand total. So I think this kind of demonstrates just how central CHP is within industrial decarbonization as well, and within industrial processes, because we have this weaker development of commercial and public CHP. It's overwhelmingly concentrated in the large industrials. And then we can see that even more in this graph, which is a breakdown of CHP by sector from 1996 to 2022. So the overwhelming majority of CHP comes from two different sectors or broader sectors. There's the chemicals industry, and we're going to have a case study on Tata Chemicals later on in this presentation. And then there's the coal extraction and oil refineries. Over time, especially the oil refineries have become more relevant as Britain has generally phased out coal over the past few decades. So some of the big sites are, for example, ExxonMobil in Fawley down in Southampton, and then a lot in the industrial clusters around the Humber in the north of England, the northeast around Hull. And then you've got some other sectors. So food, beverages, and tobacco have remained fairly steady throughout the past decades. A lot of this is because of the positions of these actual or the sites of the food and beverages industry, where a lot of them are in dispersed areas far away from clusters. So electrification, hydrogen, biomass are not necessarily feasible options as of yet, which means that for the kind of electricity and heat loads that you need, you have to rely on CHP. So one of the biggest food and beverage users of CHP is British Sugar in Norfolk, which uses a few embedded CHP engines for their electricity and heat needs. Then you've got quite a small, narrow section here for iron, steel, and non-ferrous metals. Then electricity, steam, gas, and air conditioning supply, again, quite a small section. Paper, printing, textiles, and leather. So similar to food and beverages, these sites have to locate near to raw materials, which means that they're in areas of quite high grid constraint, which means it's harder to electrify or to get hydrogen or carbon capture and storage. So a lot of them are still quite reliant on CHP, even if they don't necessarily need the really high grade heat loads that would be necessary in, say, chemicals or in coal extraction and oil refinery technologies. Then public administration. So this has mostly been for universities and hospitals. I'm going to talk a bit about the government supports for CHP as well, but generally in the past few years, public support schemes for decarbonization in public administration have moved against CHP and gas-fired CHP, which has led to a declining uptake in the past few years compared to this really quite steep growth throughout the 2010s. Then agriculture has remained a fairly steady but small portion, and commercial CHP as well has been steadily growing, especially with the introduction of micro CHP in recent years. And then one of the big changes you can see as well is for renewable share of CHP. So this is through biogas and hydrogen mostly, although the hydrogen is fairly constrained towards the big industrial clusters of the UK, There's a government plan for a hydrogen network to come out by the 2030s, although this has been fairly limited in terms of its actual rollout to date, and the funding mechanisms are still quite unclear. So it's not entirely certain whether most dispersed sites will actually be able to use hydrogen or combine carbon capture and storage in the future as well. So yeah, I wanted to go through a few different case studies just on sites in the UK and especially on sites that are looking to decarbonize their CHP as well. So Kirkwall up here in Orkney, not one we're going to go into detail on, but it's the first 100% hydrogen combined heat and power. It's for an airport on the Orkney Islands. So big tourist destination, limited links to the mainland apart from this airport. And 2G have put in these 100% hydrogen CHP engines as well. So the two that we're going to look at are the Humber Zero project. So the Humber is home to two of the UK's 6 oil refineries, the second largest chemicals and process clusters, and one of only 2 integrated steelworks in the country. Providing steam and electricity to this cluster of industry is VPI Immingham, one of the most thermally efficient CHP stations in Europe. There are 55,000 jobs in the manufacturing sector alone in the region, and 20% of the economy's entire GDP derives directly from heavy industry. Humber Zero will ensure the continued success of the region by converting industry and safeguarding jobs towards achieving this goal of local low-carbon economy. This will include significant investment towards decarbonizing steelworks and shifting refinery production towards the zero carbon economy, for example, by producing inputs for lithium ion for electric vehicles and processing waste oils and biofuels. To power this transition, the cluster will integrate CCUS and electrolysis from renewable electricity to produce both blue and green hydrogen for industry and up to 1 million homes, with the potential to remove up to 8 megatons of CO2 per annum from regional emissions by 2025 and up to 50 by 2040. The VPI Immingham CHP plant is already capable of burning hydrogen as part of its fuel mix. Humber Zero will increase Immingham's capacity to process hydrogen, resulting in the generation of up to 350 megawatts of carbon-free electricity and reducing the CO2 footprint of VPI and the adjacent refineries by 2.75 megatons per annum. Crucial to the project is the versatility of CHP in its ability to make use of either green or blue hydrogen and the thermal efficiency of the CHP plant in supporting the project's overall cost effectiveness. So you can kind of see from the geography of the Humber as well that carbon capture and storage is quite an important part of this decarbonization route. And that's because of the North Sea shale shelf, which is one of the largest natural depositories for carbon. So the UK government is generally rolling out its carbon capture and storage projects through tracks. The Humber is track 2. So that means that there's going to be a production and business model for carbon capture and storage for various enterprises in this area. And then the other case study we have here is Tata Chemicals. So based in Runcorn on the site of a former ICI industrial complex, Tata Chemicals is one of the largest factories in the Northwest and the UK's only manufacturer of soda ash and sodium bicarbonate and a major producer of salt. The industrial site has a large CHP plant with a capacity of 96 megawatts that produces significant volumes of steam and electricity needed for the site and surrounding factories. In 2019, Tata Chemicals received planning permission for the UK's first ever industrial scale carbon capture and utilisation plant, with funding from the Tata Chemicals and UK government's carbon capture and utilisation demonstration programme. Tata Chemicals is the largest single site user of liquid carbon dioxide in the UK, and through the CCU scheme, carbon dioxide will be captured from the flue of the CHP plant, purified and liquefied, and then used to manufacture salt. In doing so, the CCU plant will capture 40,000 tons per year of CO2, will reduce emissions by 11%, and will reduce the carbon footprint of the soda ash to half the European average. So why CHP specifically for both of these sites versus, say, electrification or a non-CHP hydrogen engines? Well, the CHP's production of steam and electricity for export are crucial to making the CCU scheme economically viable. Gas boilers producing high-temperature steam only would not be cost-effective. The first phase of the CCU will bring electricity export down to 202 grams per kilowatt hour, and second down to 114 grams per kilowatt hour, or half and almost a quarter, respectively, of the emissions of a combined cycle gas turbine producing electricity only. So what's the future prospects for CHP within the UK then? So for new gas CHP, the fundamentals in a positive spark spread and a short payback periods will continue supporting the market. Britain has one of the highest wholesale electricity prices in all of Europe. So the spark spread is likely to remain positive into the future. And there's been very limited talk of rebalancing these prices from within government as well. Decarbonisation targets, regulation, and restrictions on finance might reduce the viability of gas CHP in the public sector specifically, and in heat networks markets as well. So in the public decarbonisation scheme, that's where hospitals and universities are being given funds to decarbonize their electricity and heat. Gas CHP is not eligible at the moment as part of those schemes, whereas it previously was. In some cases, industrials may need to replace assets before zero carbon options are available as well, as incentives have generally been stripped back for CHP over the years. For existing gas CHP, those with gas CHP engines and turbines will continue to maintain their assets, and the only exception is whether planning standards bring forward a replacement of CHPs in existing heat networks. So previously, as was mentioned, heat networks have been fairly limited in the United Kingdom for a number of reasons, particularly given the weakness of local government planning. But new zoning regulations are coming into force in the next couple of years. And this combined with the likes of including energy from waste facilities in the UK emission trading scheme mean that there is scope for various sorts of CHPs within heat networks going forward as well. So for zero carbon CHP, hydrogen clusters will see some fuel switching of turbine CHP in these areas. So Tata Chemicals and Humber Zero are prime examples of this. They're within heavily concentrated industrial areas. So they've received the first batches of hydrogen that are able to be produced within the UK. And then biomass and waste-led energy from waste will be encouraged to increase heat offtake through CHP as well. So the biomass strategy of the UK government has a fairly limited role for CHP going forward as well, mostly concentrated on the aviation industry and green fuels for that, and on biomass carbon capture and storage as well. But especially in domestic, there is room for biomass CHP in the future, especially given that this will qualify for various subsidy schemes that are currently in existence. And then what kind of future role can CHP play in the UK? So during the 2030s and beyond, it still has a role in providing high-grade heat. So high-grade steam using decarbonized fuels is going to be more expensive than it is today, and using CHP supports efficiency, especially given the initial scarcity that we're likely to face for things like biomass and biogas and hydrogen as well. It has a role in providing low-grade heat as well. So the heat network sector are focused on energy from waste as a strategic source of heat. So that's from the likes of Veolia, which have some of the largest energy from waste plants in the UK, and Adena as well, who are planning on building out a large energy from waste / heat exporting plant in the north of England. The trajectory for smaller commercial and public sectors is unclear and will depend on wider national access to decarbonized fuels or otherwise limited to areas of hydrogen production. So the UK government has generally tended to favour heat pumps in its policy, although there's been a recent backlash against that from within the Conservative Party and the Prime Minister as well. So it remains to be seen what kind of role efficient micro CHP can play in home heating. And then its role in the electricity system. So CHP will probably need to shift to a more extreme peaking role, providing more flexible, firm power when needed, and the future of private wire is unclear and currently subject to reform. So at the moment, in terms of actual incentives for CHP in the UK, most have been removed. The remaining ones are on the CHP QA scheme. So that's a CHP quality assurance scheme, which is basically looking at the primary energy savings and then the heat to electricity ratio of plants. And if you qualify for that, then you receive exemptions from various carbon taxes. So there's the climate change levy, which is something that was introduced in 2001 by the UK government and charged on most non-domestic supplies of energy. and used as fuel for lighting, heating, and power, and also on the UK emissions trading scheme as well. So the carbon price floor was introduced on fossil fuels used to generate electricity, and the carbon price floor is made up of the UK ETS and carbon price on a UK-only tax known as the carbon price support. Supplies of coal, gas, and LPG used in most forms of electricity generation are liable for the CPS tax, and a CPS tax does not apply in Northern Ireland due to the common electricity market with the Republic of Ireland. However, it's unclear exactly how these schemes will support CHP going into the future, especially considering that at present they only apply to gas-based CHP. So when CHP moves towards hydrogen or biomass, because most CHP engines that are being produced today in the UK are hydrogen ready, those exact schemes will not provide the same level of savings or subsidy that they have in the past. So there has been some talk of perhaps just a subsidy based on primary energy efficiency being completely fuel agnostic, but it remains to be seen how the long-term trajectory of CHP policy is going to go in the next couple of years. And then finally, this is just a couple of projections that we did based on the future role of CHP in the energy system. So the future energy scenarios are produced by the electricity systems operator in the UK. They're just a forward projection based on a few different scenarios of decarbonization. And you can see here the different roles for CHP within those scenarios. So CHP becomes a net contributor of carbon by 2030 if there is a limited exposure to wholesale prices, whereas when there is retail price sensitivity, so essentially when CHP is exporting to the grid and responding to the lower prices of renewables as they're ramped up, then CHP will never become a net contributor of carbon, as the fleet will gradually ramp down or switch to different fuel sources in response to these periods of high peaking renewable generation, while still kind of maintaining that backbone of energy capacity and security and inertia for the system. So you can kind of see that demonstrated here just in terms of how the load factors would change with retail price sensitivity under these two different scenarios of decarbonization. So this kind of steepest decline from pure CCGT without combined heat and power, and then these steadier declines for more efficient CHP natural gas uses. So yeah, thank you. There's my email as well if anybody wants to contact me afterwards.
Thank you, Ots. Thank you very much for the very highly detailed presentation on the past, present, and future of the CHP market in the United Kingdom. So I propose we open the floor for discussions with our distinguished presenters. So I see Nazar, you raise your hand. So please go ahead.
Yeah, thank you. Maybe I'll start from the end. Oz, you mentioned that the spark spread, the price of electricity ratio to gas is favorable to CHP in the UK. But you mentioned as well heat pumps, and there's some disputes about in the government, which about the problem I can see, and maybe I don't know whether you agree with that. That one of the reasons that the heat pumps have actually installation in the UK have gone much lower than the government has hoped. It's probably most probably is largely related to that large spark spread. So, but you said that in the longer term, we'll still expect the spark spread to keep the same level to favor CHP. So, so how you square the circle here? How would we allow actually heat pumps to take place if we are doing that? It looks to me like a riddle.
Yeah, so in terms of the spark spread, a lot of the wholesale electricity price difference in the UK as well is because of the policy burden that's placed specifically on electricity rather than gas. So that's likely one of the reasons that you've seen lower heat pump uptake in the UK. Another is just because of the unique building stock of the UK as well. It's got the highest proportion of buildings still in existence that are from before the 19th century in Europe. So that has meant that it's difficult to get a lot of heat pumps into the system. And yeah, I should clarify that the spark spread into the future remaining positive for CHP is mostly based on projections into the late 2020s and early 2030s. So it might be that after the 2030s, that specific spark spread is less favorable to CHP and more favorable to heat pumps in the UK as well. Thank you.
Thank you, Odds. So I do not know if there is somebody else who would like to ask a question immediately. Okay, so Kirti, please present yourself and then feel free to ask your question. Thank you.
Hi, Hans and Oz. Thank you so much for your informative presentation. So I would like to ask a question from both of you, as I've seen from the presentation of Hans that the CHPs have been successful and increasing. The market is increasing in more the developing countries where the demand is increasing, and has been fairly stable in the Europe. And mostly it's still driven by solid or gas fossil fuels, and there hasn't been much increase from the biomass and hydrogen CHPs. So what do you see like in the long-term future? Okay, I agree with the gas CHP, there is intermediary future, but do you think that all the CHP will rely on hydrogen biomass? Because as the government and as per the aim of the decarbonization, more and more countries are moving towards the electrification, and that's their aim and overall target. So I cannot see the clear picture of CHP in the long-term future. And when you talk about flexibility, then it will be only for peak load, right? And I don't think so we will have more investor, or you will make a very profitable business case for CHPs. So I would like to know your opinion, and based on the studies, what do you think about the long-term future of the CHP in the UK as well as generally in Europe, or is it going to be successful mostly in Asia or other parts of the world?
Okay, well, maybe I can kick it off. I'll start with Europe because I know that best. In my presentation, I highlighted the fact that the share of renewable-based CHP has actually doubled in the past 10 years. So from around 13% to 25%. And that's mainly biomass. And you see that use in countries like Denmark, Sweden, Finland. However, we do see further introduction of biogas and also waste heat and different markets, and in particular in combined use with district heating. In terms of fuels such as coal, I mean, Germany still uses a significant amount of coal, and that's actually used to match peak demand, especially in the winter. Seasonality is a huge issue. So peak demand can, depending on how efficient your system is, it can raise, and just focusing on the building stock, for example, from 150% to 300% in the winter. And assuming you had a less efficient energy system, it could go up to 500%. So there is still today and will be a growing need for dispatchable electricity generation, and CHP can match that and complement the electrification and the demand from electric vehicles and heat pumps. So there's certainly a match for those two different technologies, and you see more and more of those technologies being sold together as a package. And then looking at coal, and especially in Central Eastern Europe, Poland obviously relies up to, I think, 65% of their electricity generation from coal. Well, PGE, one of the largest utilities, is investing massively in building gas-based CHP, especially for district heating purposes, with the view to eventually feed those on decarbonized gases. It's impossible to retrofit your coal-based CHP with gas, so you just have to build a new installation altogether. And with relatively little investment and technical difficulty, gas-based CHPs can be retrofitted to run on different blends of decarbonized gases and natural gas, maybe biogas, biomethane, or green hydrogen, up to 100%. There are many examples, and Oz mentioned a number in the UK, especially engine-based CHP using natural gas, and we see that also popping up all around Europe. So it's not a technology issue, it's not a research and innovation issues. These technologies exist, and they're being deployed more and more so across Europe. Maybe I'll pause there and let Oz jump in from a UK perspective.
Yeah, so it's quite a hot button topic at the moment on the pathway to decarbonization, and whether that's electrification or hydrogen and CCUS in the UK. So there's a big divide between, say, the government's own projections, which are quite reliant on a hydrogen network being built out and a CCUS network being built out as well, versus, say, the Climate Change Committee, who see a much larger role for electrification in that. The big constraint at the moment is just connections times and the actual grid infrastructure for electrification. So for a lot of our members, even those who are trying to connect to the grid with generation or with batteries, they're facing connection wait times of up to a decade, which just means that it's not entirely feasible at the moment for them to do any kind of long-term business planning on that basis. So there have been some reforms that are being pushed through on spatial energy plans, just trying to actually build out the UK's transmission network infrastructure so that you can have transmission waiting times. But that's something that's yet to be rolled out. And there's a lot of contingent factors there in terms of planning reform and being able to build that out. And then, yeah, just kind of echoing what Hans said as well about the role for CHP in terms of peaking and the efficiency, especially in the UK, the capacity market is quite a large part of the business case for CHP as well, just because it's quite an efficient means of providing flexibility to the system and providing backup capacity to the system as more renewables are rolled out. So that's something that a lot of our incumbent CHP members have also seen as some of the other incentives or subsidies have been pulled away, that the capacity market is a large part of their business case going forward.
Thank you, Hans, and thank you, Oz, for the detailed answers, actually. So it is interesting to see how this market will look like in 20 to 30 years time from now. And I see some other people in the who would like to ask a question. So Gohari, so I would ask you if you could identify yourself, and then please feel free to ask questions. Thank you.
Hello, this is Hamid Reza, Staffordshire University, UK. Thanks for the presentations, both Hans and Oz. Brilliant stuff. My question is about the technology prime movers, and what is going to be the share of each prime mover in terms of micro CHPs by 2030 or beyond? Is it going to be more in favor of piston engine sort of CHPs or Stirling engines, fuel cells or micro gas turbine systems? Is there any indication of which technology is going to receive more share of market and more attention in the next decade or so?
That's a tough question. I don't have specific statistics on micro CHP in Europe. We know that there are over 100,000 units deployed across Europe. I believe they're mainly Stirling or internal combustion engines. But from what we've seen, at least, the market is relatively stagnant. There is an uptake of fuel cell micro CHP, and that's been heavily supported and subsidized with EU project money. There are two particular projects that involved COGEN Europe by coincidence, both Enfield and Pace, and both of these EU-funded projects I think totaling over 150 million euros, were to support the uptake of fuel cell micro CHP across Europe, to reduce the price of manufacturing, to bring the technology to scale, and through the PACE project, at least up to 2,500 units were deployed across Europe, trying to mirror, I would say, the success that fuel cell micro CHP has seen in Japan through the NFARM initiative. That was also largely supported and subsidized by the Japanese government. Moving forward, I think, yeah, fuel cell micro CHP has a role to play. Even today, even with natural gas, you're still saving up to 30-35% in terms of greenhouse gases. You eliminate the issue of clean air through the elimination of combustion. And micro CHP has a future, especially with the use of biofuels, different ways, different technologies, micro gas turbines, certainly, using different fuels in the most efficient way possible. So, I mean, in general, I think you see a larger penetration of micro CHP in Europe, especially in Japan, South Korea as well. And you see more and more micro CHP being used in North America and in America in particular, especially for like data farms and server farms, excuse me, and things like that, in terms of resiliency, but also in terms of efficiency.
Yeah. Oh, sorry. Do you want to follow up there? No?
Yes.
Okay. Yeah. So in the UK as well, I don't have the exact figures for the uptake of the different engines. Although I've read a couple of studies saying that the best business and environmental case, or economic and environmental case in the UK specifically, is fairly even between Stirling engines and internal combustion engines for micro CHP. I can send on that study to you afterwards as well, but it's just that the building stock in the UK as well, because of the older building stock, these are the micro CHPs that make the most sense compared to heat pumps at the moment.
That's great. Just in terms of some of the products are being discontinued, like the one Baxi offering with Stirling engines in some size, Viessmann and Panasonic, the fuel cell one. So maybe they regain the market again, but there has been a period of time. I remember it was in an exhibition in London a few years ago. Viessmann with that 1 kilowatt fuel cell micro CHP, they were struggling to sell it to market because of the high price. So I think there are different parameters, as you mentioned, but technology-wise and availability of product is another angle, perhaps in your reports, can be kind of considered to be investigated and reported on. But anyway, thanks, Hans and Oz. Well answered.
I direct you to the PACE website, because this was an 8-year project in the end, and you can find a lot of information about the project through the final dissemination event, and looking specifically at the markets, the technologies, the deployment. But I know for a fact that the Viessmann, for example, from a fuel cell micro CHP perspective, Viessmann, Cenertech, which is part of BDR Tormea, which is part of Baxi, is one of their brands, Solid Era. They're all still selling fuel cell micro CHP in Europe, and they were part of the EU-funded PACE project. I myself have a solid oxide fuel cell running in my basement. So,
all right.
Good experiences, good return on investment, interesting technology. It is a bit still pricey, but there were incentives at a local and regional level in Belgium. So, very good spark spread still. So, an interesting technology.
Can you share the link to that website, Hans, in the chat?
Yeah, no problem.
Thank you. Thanks, Nicolò.
Thank you to you, Hamid Reza. I do not know whether other participants would like to ask other questions. Okay, so I would have one general question for both Oz and Hans. because today one of the main main conclusions, both for the markets in Europe and in the UK as well, let's say also in general, in the UK and also in the continental Europe, was that we have a complexity of regulation and administrative burden, which is somehow an obstacle to the deployment of more efficient CHP that could also use the biofuels or low carbon solutions. So my question to you is, if you have three priorities, I mean, what would be the three priorities to enable, in the regulation, to enable the deployment of these technological solutions?
Yeah, I'm happy to go first. So, yeah, administrative burden is quite a big issue in the UK, especially of CHP. Traditionally, CHP has fallen between a few different departments and government areas, which means that a lot of the actual legislation doesn't line up time-wise. So, for example, I was just talking to one member who is having trouble participating in the capacity market because their valuations from the CHPQA scheme, so based on their efficiency, are too old in terms of their kind of annual rollout, which means that there's essentially 3 months throughout the year where they just can't participate in the capacity market because the data is out of date. So a lot of the complexity boils down to this traditional subsidy scheme for CHP based on carbon pricing and also on specifically gas CHP as well, having these subsidies. So one kind of new methodology that could work better is if there were a technology neutral subsidy based on those CHP QA criteria. So on the energy efficiency and on the kind of electricity versus heat load of the system as well, which would simplify things and make it a lot clearer how you can actually participate in those systems. Yeah, that would be the main kind of takeaway in the UK.
Well, I can only echo what Oz said. In Europe, well, we have various different levels. So you have EU legislation, and I'm sure at this point everyone's heard about the European Green Deal and the Fit for 55, and it's a slew of different legislation, new legislation, revised legislation aimed at helping the EU reduce its greenhouse gas emissions by 55% by 2030. And in some way, all 50 plus proposals have had an impact, positive and negative, for CHP. Although the big ones that we focus on specifically is the Energy Efficiency Directive. There's a revision of how high efficiency CHP is defined, and other directives such as the Renewable Energy Directive, the Emissions Trading Scheme, extending the Emissions Trading Scheme to buildings and transport. So just at a European level, my point is that there is a lot of legislation, and all of this is coming to an end in terms of the legislative process. So at least the Energy Efficiency Directive and the Renewable Energy Directive is already legally binding, and member states have 2 years to transpose that into national legislation. And that's where things get a little bit more complicated, because not everything is transposed in a harmonized way. And so that's why you have some distortions in the markets, and different countries interpret the rules differently, let's say. So there is a significant burden in that respect. Another thing is that there's a lot of support schemes in place, because CHP typically has a higher capex compared to other technologies. So there are support schemes in place. Unfortunately, it's like a on-off button, and it makes it very difficult for CHP operators to run economically, at least in the medium to long term, because these incentives are introduced and then removed after 5 years and then reintroduced, but maybe more complex with an additional administrative burden. So that makes it all very difficult. So in some ways, the top-down approach doesn't necessarily always work. And we're very much pushing for a bottom-up approach where that's possible, and really focusing on system integration. There is no silver bullet. That would be my second recommendation. The electrification is a solution. It's not the solution. And we need to see that with thermal power generation, and CHP in some sense complements the route to electrification through the use of renewable energy sources such as wind and solar.
Thank you for the comments on this legislative legislative topic. And indeed, what I also saw in the office when I was doing a bit of research with my colleagues was this imbalance, this difference in terms of national implementation of the plans. So this will of the legislation. So it will be worth it, in my view, analyzing how this process of implementation of the EU policies will be run in the next 5 to 10 years. Also considering the integration now of renewable energy sources also for the CHP. And equally, it is interesting to see the advancement and the obstacles in the United Kingdom. So at the end of the day, my personal view is that the UK has some good examples that could be taken for the European continent, so to say. I do not see any further questions from the participants, so I'd like to ask if anybody would like to ask one final questions to Oz or Hans or both. We still have a few minutes, so feel free. Okay, I do not see further questions. So in case there is no further questions or comments, I propose we can proceed to the closing of this webinar on the overview of the CHP market. So I'd like to thank you again, Hans, Ots, for your work, for your presentation, and for your availability to present at our webinar series. And just for you to know that ETN is really organizing the second episode of the Decentralized Energy Systems. The second episode will be on the modeling tools and solutions for decentralized systems. And we'll have 2 presentations from 2 EU-funded projects. So just for your information, that we'll keep on going with this series. We hope you enjoyed this webinar. You found it useful. You learned something new. And thank you again for your participation.